The product formula of complex numbers can also be used to help us when we're using powers of numbers. For example, consider z, if we write it in trigonometric form, we get the magnitude of z times the cosine of theta plus I sine of theta. But imagine if we wanted to square that. So if I want to square this, notice I'm going to have to square the whole thing here, which is going to give me the magnitude of z squared. And then when I multiply everything out there, I end up with the cosine of 2 theta plus I sine of 2 theta. Similarly, if I move down to z cubed, notice that z squared times z. So I can rewrite the method of z squared that I have above. So I have the magnitude of z squared times the cosine of 2 theta plus I sine of 2 theta times the magnitude of z cosine of theta plus I sine of theta, which results from using the product formula of the magnitude of z cubed cosine of 3 theta plus I sine of 3 theta. And if we use Euler's formula, it's even more apparent, the reduction in work here, because z to the n becomes the magnitude of z e to the I theta to the n power. But remember that we're just adding all of those arguments together, which gives us the magnitude of z to the n e to the I n theta. Much easier than having to multiply everything out. That observation leads us to Demoivre's formula, Demoivre's theorem, which tells us that if we have this z and a positive integer n, we can write it in this formula quickly. We do not have to multiply it out n times. And then using Euler's formula, we can put it in this format. So let's use Demoivre's theorem. We could do the square root of 3 minus I times itself 7 times, or using that formula, we know that the square root of 3 minus I to the 7th power becomes the magnitude, which when we calculate that is 2, so 2 to the 7th, and then e to the 7I negative pi over 6, which we can find that pi over 6 using our formula to find the argument. And this leaves us with 128 e to the I negative 7 pi over 6, or if we want to change that to a positive exponent, 128 e to the I 5 pi over 6. And just as a reminder, remember we're getting that theta by the inverse tan of b over a. Our b is -1 over the square root of 3. And the 5 pi over 6 and the 7 pi over 6 translate because we have this will bring us to -7 pi over 6, and this brings us to 5 pi over 6.